So what if empty space isn't actually empty? I mean, what if it's more like ketchup? Yeah, you heard me right. Today we're going to dive headfirst into a really fascinating and, let's be honest, pretty unconventional theory of cosmology. It's called substrate dipolar magnetic topology, or SMDT for short. And believe me, it proposes a completely radical new vision for the very fabric of our universe.
Okay, so here's how we're going to break this down. First, we'll get into the theory's wild idea that space itself is a kind of fluid. Then, we're going to try to crack what it calls reality's secret code, a single equation that supposedly builds everything. From there, we'll see how that equation becomes a ladder to reality and explore this amazing idea of the music of matter. And finally, we'll ask the big question, how could you possibly test a theory this strange?
All right, let's start at the very beginning with the absolute foundation of S-DMT. This theory starts by taking our most basic assumption about space, that the vacuum is empty, and it just throws it right out the window. It suggests that what we call empty space isn't a void at all. It's actually filled with something pretty peculiar.
Now, in mainstream physics, the standard model says the vacuum is a quantum field, kind of buzzing with this low-level energy. But SMDMT, it says, nope, that's not it. It completely tosses that idea aside and replaces the abstract quantum field with something way more tangible, and frankly, a lot weirder.
And that peculiar substance is what scientists call a thixotropic fluid. This isn't science fiction, by the way, it's a totally real physical property. I mean, if you've ever had to smack the bottom of a ketchup bottle to get it flowing, you've actually seen thixotropy in action. It's a fluid that acts like a solid when it's just sitting there, but turns into a liquid the moment you apply some stress to it.
And right here, this is the crucial leap of faith the theory asks us to take. It's saying, stop thinking of space as a passive, empty stage. Instead, imagine an active, physical medium. In this model, the fluid isn't just in the universe, it is the universe. And get this, the theory claims that all matter, every particle, every star, every planet, is just a temporary knot, a kind of standing wave that's created by stressing this cosmic fluid.
Okay, so if the universe is really a giant tub of cosmic fluid, how in the world does it create everything we see? How do you get from, well, cosmic ketchup to complex particles and even people? Well, let's take a look at the mathematical engine that supposedly drives this whole thing.
So, according to the SMDT model, it all comes down to this one single formula. It looks simple, right? It basically describes a whole ladder of stable frequencies that can exist within the fluid. That F0 is just a base frequency, and K is a simple integer, 1, 2, 3, and so on. But the real secret ingredient, the number that supposedly makes the whole thing work, is that constant, beta.
This constant, beta, has a value of about 11.653, and they call it the winding pitch. Just think of it like a magic number, or a fundamental recipe for the universe's fluid. It describes the exact geometric ratio of twisting you need to apply to make that fluid form a stable, self-sustaining wave. And in this theory, what are those standing waves? Well, they're what we call particles.
Now this is second key constant here. It's called gamma, or the hysteresis coefficient. This one basically represents the fluid's internal friction, its stickiness. It's a measure of how much the fluid resists changing its state. You can almost think of it like cosmic molasses.
Now here's where things get really bold. The theory claims these numbers aren't just pulled out of thin air. It actually tries to derive beta from other fundamental values in physics. It starts with a number that's pretty famous in physics related to electromagnetism, then it makes a little adjustment for that fluid stickiness, and then it spreads that correction across a series of theoretical layers. And the claim is, when you run all those numbers, you land precisely on 11.653. It's a really audacious attempt to show that this constant is baked right into the fabric of physics itself, not just invented for the theory.
So, we have a fluid and we have a formula. Now, this is where we get to see the theory's most ambitious claim in action. What actually happens when you just start plugging simple, whole numbers like 12 or 21 or 23 into that K value in the master equation.
The results are, to be honest, pretty astonishing. Each integer you plug in for K acts like another rung on a ladder of reality. So you plug in K equals 12, and the formula spits out an energy that perfectly matches a key vibration of the water molecule. You jump up to K equals 21, and you get a value that's incredibly close to the mass of a proton. Go to 23, and boom, there's the Higgs boson, the famous God particle. And one step higher, at K equals 24, you find carbon, the very backbone of life. I mean, the claim here is absolutely incredible. It's a periodic table for all of reality, generated by just one simple integer.
And from here, the theory takes a really unexpected, almost mystical turn. It tries to connect the hard physics of particle energies to the harmonious world of sound and vibration.
The theory essentially proposes that what we call fundamental forces aren't really forces at all. Instead, it suggests that particles are held together by a kind of musical harmony, a perfect, stable resonance that exists within this universal fluid.
So to illustrate this, the theory does something pretty cool. It takes the super high frequencies it predicts for water and carbon, and it just keeps lowering them, octave by octave, kind of like finding the same note on the lower and lower keys of a piano, until they're in a range we can actually hear. And the result is kind of amazing. Both water, which is the solvent of life, and carbon, the backbone of life, land on the musical note C. It's like they're harmonizing on the exact same fundamental note.
And this idea, it extends to the very structure of molecules. The theory reframes chemical bonds, like that famous 104.5-degree angle in a water molecule, not as the result of electrons being shared, but as a point of stable, consonant resonance. That angle is the exact shape the molecule has to take to perfectly balance the music of its parts within the fluid all around it.
Okay, let's take a breath. This is all really fascinating stuff, but it's also incredibly speculative, right? So how does something like this move from being just a wild idea to becoming actual science? Well, the answer is simple. It has to make predictions, specific predictions that can be tested in a lab and, this is the important part, that can be proven wrong.
And really, this is the absolute heart of the scientific method. It's called falsifiability. A real theory has to make a risky bet. It has to predict something very specific about the world. And if that prediction fails when you test it in an experiment, the theory has to be thrown out. It doesn't matter how beautiful or elegant it seems.
And you have to give it credit. The S-DMT white paper does exactly this. It lays out at least 3 specific, measurable predictions. It predicts that if you put atoms under intense mechanical stress, their light spectra should measurably shift. It predicts that the mass of the Higgs boson isn't actually constant, but that it should change just a little bit in different environments. And it even predicts that you can physically bend the angle of a water molecule if you can hit it with enough shear stress. And the crucial thing is, these are all things that could, at least in principle, be tested with today's technology.
And that leaves us with one last really provocative question. In science, it ultimately doesn't matter how strange a theory sounds. If it makes new, specific, and testable predictions, and if experiments actually prove those predictions are right, then we are forced to pay attention. So the question that S-DMT leaves us with is pretty simple, but it's huge. What if it's right?